Calculus AB, AP, Tuesday, April 4th. We're starting with the end of the 8-2 notes. So we got a particle moving along a horizontal line. Yay, I love horizontal lines, okay? Okay, particle moving along a horizontal line, okay? They want all the values of t when the speed is 5, okay? So they give us the velocity function. What's the speed function then, if we know the velocity function? Yeah, it's the absolute value of speed, right? So the way I like to do it personally, right? So I like to plug in the velocity function here. Okay. Yay, look. Velocity function. Okay. Then on y2, what I like to do is I like to just make it the absolute value of y1. Okay. So I've got speed graphed on that second line, okay? And we want to know where that equals what? 5, okay? So I'm going to graph the absolute value in that 5. My window's going to be from 4 to 7. Where did I get that from? Yeah. The parameter, right? From t greater than 4, less than 7. Okay, so there's two solutions here. I'm just going to calculate the intersect. So the first one's going to be 5.621. Second one is going to be 6.520. Hopefully you guys remember that intersection function on your calculator. Yeah. Okay. Write an expression involving an integral that gives the position s of t. Use this expression to find the position of the particle at time t equals 3. So this was, okay, so they give us an initial value here. Right? They give us an initial x value, and they give us an initial y value, right? Okay, so how do we write down the position function? Yep, so just as velocity is the derivative of position, position is the antiderivative of velocity, okay? So it's going to be the antiderivative of velocity, okay? What do I put in my limit spots at the top and bottom of that little s symbol? 0 to t. Where did that 0 come from? That's your initial x they give you. So let's do that in like blue. Do it in sky blue. Okay? And then how does that minus 3 get taken into account? You're going to do minus 3, yeah, outside the integral, okay? Right, and that makes sense, right? Because if we were to plug in 0 for t, this would be the integral from 0 to 0. That would just be 0, right? That would go away. And then we'd have to be left with negative 3, right? And then it says use this expression to find the position of the particle at time t equals 3. So then we want s of 3. Going to be just plug in 3. Okay. So on my calculator, I've got y1 plugged in. That's the velocity function. Okay. So I'm going to do math fn int from 0 to 3. Of y1 dx minus 3. Okay? Any questions there? So the position is negative 6.263. Feeling okay? Okay. C, find all the times in the interval when the particle changes direction. At what? When what changes? Changing direction. Changing the direction in which it's moving. With what? Velocity. Yeah. So this actually isn't really a calculus problem, actually. You just go to the graph of velocity. So find all the times in the interval. So you just have to go, we're going to make our x-min 0 and our x-max 8. Okay. I'll make my y-min like negative 30, I guess. Graph it. There you go. So the answer is... it has to change sign, right? So it can't just be where it touches 0. It has to be where it actually crosses the horizontal axis. So let's see if it gives me that. All right, so does it actually cross there? I don't think it actually crosses there, does it? Okay, this is, I feel like this shouldn't be the answer, though. I don't know. Just have lunch.
Were you a part of it when you were here?
No. It started, my sister started it.
Oh.
She was the one who started it. Okay, so we have, so this 2.341, okay, so what's going on here is this is one of the answers on the answer key, but let me zoom in. It's got to actually change sign. You guys see the distinction? It can't just like touch 0. It's got to like actually cross. Okay, so let me zoom in. I'm going to use the zoom box. Oh, shoot. I'm going to use the zoom box function to zoom in. Because I don't know if the calculator is... Yeah, that does not... Oh, does it dip? Does it go through? Do you think it goes through or no?
Zoom in. More zoom in.
Zoom box.
There you go.
Zoom box.
More.
Zoom box again?
Yes.
All right. Gotta...
That's a nice eye.
I'm a crowd pleaser.
Oh.
Give it into peer pressure.
Oh my god. Where did you get the bread?
When I was... I don't know. Okay, we all know, though. It's got to cross.
Yes.
Okay, we know how to do the problem. That's cruel. That's cruel. There would be another one, right? So if we go back to that window, 0 to 8. So that would be an answer here, and then that would be an answer. And then let me whip through that last part real quick. Is the speed of the particle increasing or decreasing? This isn't too bad, right? Is the speed of the particle increasing or decreasing? So let's go back to the speed, right? I have the speed plotted on that first line. So let's turn off that third line. That was that was the absolute value. Oh, sorry. Sorry, guys. My bad. That's why. Sorry, it does change. Sorry. My bad. Okay, there you go. And then we want to see if the speed's increasing or decreasing. Oh, that's annoying. So, you guys remember talking about speed increasing or decreasing? Yes. So we have to check the sign of position and the sign of the velocity. So let's get rid of the speed and velocity. Then like my position function is math fn int, right, 0 to x. That's going to be y1 of x. Okay? And we want to see if they have the same sign at 7, okay? So instead of graphing this, I'm just going to do y1 of 7. Okay, and I'm going to do y2 of 7. Right. Same or opposite signs? So the speed's doing what? Decreasing, yep. So speed is increasing when velocity and position have the same sign. Okay? It's decreasing when they have different signs. It's velocity. All right, 12:45.
Have the same signs for
Increasing is same, decreasing is different. Just gonna keep the camera rolling.
Wait.
I'm applying for a job. I'm interviewing on Friday. Like, I want to start soon. And then be like, "Oh, you want to start?" Like, no, I can't.
Like, just
Wait, Andrew, what were you saying? football. Bruh.
Mr. Rushka,
What's up?
would you like to?
She said to me was.
I'd like to invite you to my Eagle ceremony.
Wait, seriously?
Yeah.
Awesome. When?
Let me give you
I was
the
like,
Dude, my guy.
Sunday,
I'll see if I still fit in my class A.
April 23rd
Oh, dude. Yes.
At
At
1.
St. Simon?
at Goldenberg Scout Center.
Okay.
I didn't say anything.
Dude, I'd love to come.
Tony, do I get to come?
Sick, dude.
Maybe we'll see. And it's me, Luke Pellman, and one of our other friends.
Antonio Arroyo. 1 p.m. Add people, add location, Goldenberg Scout Center.
Yes. We're having it out in the campfire ring.
Nice.
It's the, you know the Dudo Memorial?
Now it's like
Yeah.
He was our old scoutmaster. He was the
Nice.
scoutmaster of our troop. So
Nice. What troop are you?
446.
Where's it chartered?
St. Simon.
Oh, okay.
So,
It's chartered to St. Simon.
Be exempt from
Yes.
so much science and religion.
that's true. We missed like half class.
Dude, I did a thing back then. So with my left guy, all of a sudden this weird rocks keep going.
He's tried.
His huge dry is like so dry.
Oh, I hate
It's such a weird feeling.
I feel like I'm doing a problem. Yeah, well, you're gonna hit me there.
Are you watching the Are you watching the forecast for?
I'm trying to see if the roads are gonna be safe at approximately 10 p.m.
Trying to see how bad these storms are going to be
10
tomorrow.
p.m.
Oh, yeah, when are we getting hit by tornadoes?
It should have already happened. There was like a 40% chance. There's 30 throughout the rest.
No.
Sounds about right.
Wait, did I leave my water?
Every time this ball goes over my head,
I bounced off your desk when I did.
you really.
What?
It's supposed to be.
I heard your brother went to Jackson Hole and didn't know how to snowboard.
Yeah, he like broke his fingers.
Yeah, no, I
What?
He went snowboarding in Jackson Hole, and the second day he was down a black that was blue because it was a groove.
He said like the course that he did that on, it was like it was dark out, but it lit the snow, like the white path. Yeah, he didn't see like a turn. So he tumbled like 25 days.
There's a way to tumble and there's a way not to tumble.
Yeah, for sure.
Which you didn't know. You gotta make a distance where you break it.
I don't know, man. I don't know.
Because you got the stitch.
I like snowboarding a lot better though.
Thank you, Mrs. Field. All right, here we go. 12:45. Here we go. Let's get to class. All right, guys. So let's go into example number 2. There. Wait, really?
Yeah, I watched it.
Wait, really?
I just called him.
Alright, I'll email her. I just called her. What? Send a threat. Calling cloud. Subject, Brooks Lanyard.
Only other person
Hello, Colleen.
I know is
You're 100% sure she took it? I don't want to like send this email.
I watched her take
Okay.
it. So I gave it to her, but I just forgot to give it back.
Please kindly return Brooks Lanyard to her. We are in room 4340. Okay, I just sent it. I just emailed her. All right, here we go. So we've got the space shot. Anyone ever ridden or rode the space shot?
Yes.
Yes, you did. Okay. So this is the space shot. We're really chatty today, which isn't a bad thing. Okay. So at what times does the space shot change direction? This is the velocity function. So at what times does it change direction?
6, 8, 10, 14, not 14, 6, 8, 10.
Yeah, good job. Yeah, 6, 8, 10. I'm just going to go through this fast, okay? What times in the interval is the space shot the highest? When is it the highest? That's when the velocity is the highest. When is the actual position the highest?
You gotta take all the areas.
It's all the areas, right? Right, to go from velocity to position, we've got to take the antiderivative or the integral of velocity, okay? All right, and then we want to maximize the position and not the velocity, right? So let's take some areas. All right, this is 1/2 base times height, that's 10. This is an area of 4 times 20, which is what, 80? This is an area of 10. This has an area of 1/2 times 2 times 60, which is 60. This triangle has an area of 1/2 times 2 times 40, which is 40. Okay. This has an area of 1/2 times 4 times 40, so 80. So this contributes negative 60, negative 80. Okay. So after 6 seconds, it's 100 feet up. And then over the next 2 seconds, it goes back down to 40 feet. Then it goes back up to 80, and then back down to 0. Okay, so it's the highest at 6. You guys see that? Okay. So we want to know where the integral of this function is the biggest. Okay? So remember, areas above the axis contribute a positive value to the integral. Areas below contribute a negative, okay? If we integrate from here to here, that's an area of positive 100, right? If we keep going, it starts decreasing, right? And then we're back down to 40 because we took away 60. Add back 40, you get 80. Take away 80 again, you get 0. See that? So we have the biggest integral we can take over this function is from 0 to 6, which gives us 100. Does that make sense? So t equals 6. It is 100 feet high. Anyone ever been to like Kings Island or Cedar Point? Anyone ever been to Cedar Point? That place is amazing.
I wanna go.
The place is insane.
I've been to King Island like 6 times.
Really, it's crazy. Like Kings Island has like the 1 or 2 like big like signature coasters. Like Cedar Point has like 12. It's crazy. Anyway, find the total distance the space shot travels during the time interval. What do you think that would be? Yeah. So instead of integrating, so we're going to take instead of adding up. So the position is going to be the integral of velocity. Distance is going to be the integral of what, you think? Speed. Yeah. What's the speed graph going to look like here? It's going to look like this, but it's going to be positive, right? So that's going to be the speed graph. Okay. So what happens is all we do is we instead ignore the negative signs here and we add all these up. So 100, 160, 200, 280. And then D here. So valid for the time interval t between 10 and 12. So we're interested in this. So I'm going to erase the speed stuff. We're interested in this right here, this part of the graph. Okay. What is the velocity function there? What velocity is, what function is that line part of? So it's negative 10x, right? Or negative 20x? Yeah. It's negative 20x, the slope is negative 20. Okay, let's extrapolate. Where is it going to touch the...
Wait, where'd you get negative 20?
So the slope, so this is a line, right? The velocity function's a line right here. So it's going to be mx plus b.
Oh.
The slope is going to be negative 20. This slope is negative 20. You run 1, you decrease by 20.
So 200 would be the line or so?
Would it be?
So
Okay, good.
10 times 200.
Okay, yeah.
And then 100
So negative 20x plus 200. Yep, that works. So that's the velocity. What's the acceleration going to be then? This is actually pretty easy. Derivative of velocity, right? What is that here? Negative 20, yep. And what is the position going to be? Antiderivative of v of t, right? So from what? 10 to t, okay, plus what? It's going to be plus s of 10. What is s of 10? 0. There you go. Good stuff. So when you take the antiderivative, the bottom number is the lowest x. The top number is just t. And then you have to add s of the bottom number, s of 10. Questions, comments, concerns?
We just leave S of t like that?
Yeah.
Why wouldn't it be 10 to 12 and not 10 to 10?
What?
Why wouldn't the interval be from 10 to 12 and not 10 to 10?
Because they want, like, if they were to ask what is the position at 11.98, they want you something that you can plug t in. Yeah. Yeah. Okay. Actually, going back to that, we should take the. Okay, we should. Okay, on the answer key here it has v of t plugged in, so we should do negative 20t. Technically, it should be a dummy variable, negative 20t prime plus 200. Okay, this is not like the derivative of t. This is just t prime. That's just like a name. Like I made up my own variable called t prime. Because I'm cool. Plus s of 10, but s of 10 is 0. Okay. All right, example 3, quick multiple choice practice. Particle moves in a straight line. At t equals 5, the particle's distance from the starting point was 6 meters. Okay. What is the total distance? So s of 5 equals plus or minus 6. Or let's just say 6. Okay? S of 5 equals 6, right? At time 5, the distance is equal to 6. Okay? Maybe I should say absolute value. What's the total distance the particle has traveled between 5 and 10? Which one should I do? I'm thinking B. Wait, B? Wouldn't it be integral of absolute value of v of t?
But then it's total, so what happens to the 6 then?
I don't know. Oh, it's a trick question. How is this a trick question? All right, it's a trick question. Okay, it is C. Why do we not need to add the 6 there? Yes. Read carefully. Okay, read carefully. Okay. What's the total distance the particle has traveled between 5 and 10? So the starting point they gave us is irrelevant here because that was before t equals 5. So we don't care about that in this specific example. Okay?
Plus radial root 2 is just distance, not displacement. Or it's just
Yeah, displacement.
displacement, not distance.
Yeah, so that's why B is wrong. Yep. Tricky, tricky, tricky. A lot of these test your reading comprehension pretty well. All right, you guys want to do this other one, and then we should probably move on to. Particle moves in a straight line with this velocity at t equals 2. The particle's distance from the starting point was 10 meters. What's the particle's displacement between t equals 2 and 9? So we care about displacement now. So do we want absolute value of velocity or just velocity?
Velocity.
Yeah, so C and D off the table. Okay. And again, I interpret that between as don't worry about the initial displacement. So I'm going to go with B. Yep. And I'm right. Real surprise. Anyway. Sorry. Can I go on to the, I'm going to go on to the 8-3 now. Is that okay?
What about that?
Using the nut strategy. No, I don't care. All right, cool. So this 8-3 here, this is just 2 example problems. I did it in deep here yesterday, okay? So you got a zoo, all right? There's a zoo, okay? Once upon a time, there was a zoo, okay? And at that zoo, a baby elephant was born, okay? And they didn't know what to name the elephant, okay? And so what they did was they asked the visitors to drop in ideas into a ballot box, okay? While they were at the park one day, okay? Yeah, that'd be kind of fun. So the number of entries in the box, right, it slowly increased during the day, right? Someone dropped in, right, their ballot, and then like other people did, and then, yeah, okay? And this table here gives the number of entries in hundreds present after the given number of hours. So after 2 hours, there were 400 in the box. After 5 hours, there were 1,300, and so on, okay? All right. Let's approximate the rate, part A, the rate at which they were being deposited at t equals 6. Approximate the rate. What do I do whenever I approximate a rate? Slope formula. Slope formula, okay? So it's going to be 21 minus 13 all over 7 minus 5, which is 8 over 2, which is 400 entries per hour. All right. And then for part B, let's use a trapezoidal sum to approximate this integral, okay? So that's going to be our first, second, third, and fourth trapezoid. How are we feeling about the trapezoid rule? Okay. Worst drawing ever, but that's okay. Okay. So those are my 4 trapezoids. The area, do you guys remember the area of a trapezoid formula? Yep. There you go. There's your answer. Don't keep going. Just stop. They'll take that. 4-function calculator. Okay. Oh, wait. We forgot to multiply by 1/8. Multiply everything by 1/8. There you go. Yeah, be careful not to forget that. It'll be easy to forget. Okay. And then, using correct units, explain the meaning of this integral. What formula does this look like? Taking an integral and then multiplying by 1 over the difference of the top and bottom numbers. What is that? Average value, okay? So the average number of entries present in the box during 8-hour period. That looks good. Watermelon pudding.
It is good.
It is good.
Taking the lake as well, 100 milligrams.
Wait, really? Not much to Celsius. I'm still gonna drink a Celsius at some point.
You've never had one?
No. What was that?
You make me really anxious.
Really? Yeah, caffeine gives people anxiety. It gives me anxiety.
I can only drink half. It doesn't.
Really? It used to give me panic attacks for a bit.
I
Caffeine.
must have been fun in college.
Yeah, I never drank caffeine in college, really. Only a few times.
Caffeine?
What?
Why'd you drink caffeine then?
Why did I drink caffeine? I don't know.
Just 'cause?
I think I was just like really. I think I like really needed it for something.
The guy that like introduced us to Purdue, like one of the faculty members, like said, coffee will be your friend.
At Purdue.
Yeah.
I was very well rested in college. You came. Thank you. Got him. Thank you, Colleen.
Did you get his email?
Yeah, I just, honestly.
Okay, okay. So at 8 p.m., the volunteers start to process the entries. Okay? And they start to process the entries at this rate. So what is this rate? This is the rate at which the ballots are removed from the box. Okay? How many entries had not yet been processed by midnight then? Okay. So for the first 8 hours, right, people are putting entries in the box. Okay? At the end of those 8 hours, we have 2,300 entries in the box. 2,300 ballots in the box. Okay? And then they spend the next 4 hours removing them at this rate. Okay? So how would we answer the question they're asking us? At midnight, how many ballots are left? What do we do? So we start with 2,300, right? And we subtract from that what? Was that? You said P of 3? So it's not T equals 3. So this is a rate, right? We want to subtract from 2,300 the total that they processed before midnight, right? How do we go from a rate to a total? Integral, yeah. It's going to be the integral of P of T from 8 to 12 dt. All right. So you do that in your calculator, you get You get 2300 minus 1600. 700. Make sure you include units. Yeah. So be careful. This integral right here gives you 16, but you actually got to subtract 1600 because the rate is in hundreds of entries per hour. Does that make sense? Okay. All right. At what time were the entries being processed the most quickly? What do you do for that? Yeah. So if being processed the most quickly, that means the rate is maximized. So we're not going to use an integral here. We want to maximize P of t. So right here, I've graphed P of t. All right, I want to see where it's maximized. Okay. So this is actually kind of annoying how you have to justify. You have to justify your answer here with a first derivative test. So what you're gonna do is you're gonna write down the critical points here. Okay, so there's a relative max here. So 9.184. Comma 5.089. You got a relative min right there. You got to write down 10.816. And then I have to write down what for a first derivative candidates test? Endpoints. There you go. Okay, so what time, sorry, I should say T and P of T. Where is P of T the biggest?
Oh.
Yeah. So don't forget your endpoints, okay? Don't forget your endpoints. All right. Let's go ahead and stop there. Not super happy.
Can you leave it up there?
Yeah.